Talking about computer vision. So I'm Tim, and this company is the one, oh, I walked out of the video again. This company is the one that's doing that cool stuff, that holographic stuff. You don't know my companies, but you're using our software for sure. We build software for companies all over the world, including here. That Internology company is most famous recently for the US presidential thing, CNN, the broadcast TV software for CNN. And I'm told, I'm here late at night with you people without beer, and I'm told that you guys want to hear about this president we have in the United States. That he's actually on the news quite a bit here. And I can tell you some amusing stuff about this guy because we built all the software for the United States presidential elections. So we're going to talk a little bit about that because it's amusing, and I'm not a fan of this person. In fact, I don't think I know anybody who's a fan of this person. I know one person that voted for this person, and that's interesting. So you hear all these conspiracy theories, and then we're involved. So we can speculate about, and I will. I'll speculate what actually happened. So I've been doing this a long time. It's truly a pleasure and easy for me to speak in front of a bunch of smart developers like you guys. Are you all developers? Everyone's a developer here? No one's going to admit that they're an overpaid designer? No? I don't see any black turtlenecks. Okay. So I've been doing this a long time. You don't know me, my companies, or my face, because throughout my career, I've often stood next to the big guy, and that's fun. And I'll probably be standing next to the big guy in a couple weeks at Microsoft's largest conference, which is called Ignite in Orlando in 2 or 3 weeks. And I have a demo. Was anybody in my last session from here? Darn it. Can I do the killer demo? Do you mind if I do it again? Is that all right? Okay, I have a killer demo that Satya Nadella, the CEO of Microsoft, has seen and was so moved that it brought him to tears. It's amazing computer vision stuff. And if you guys don't mind, I'll duplicate a little bit of the demo and content, you two guys, because it is computer vision, this talk, just a little bit higher level. The bummer about Internology is most of the work we do is protected by NDA. That Apple telephone that you have in your hand, you know, there's a good chance we built some of that. Your Android phone, Windows, Google, Apple, Nike, NASA, you know, Intel, we build custom software. And these are some of the companies we're allowed to talk about. And the CNN folks, it's a godsend they allow us to talk about that. Here's a bunch of famous people, at least famous in the US. Actually, those are worldwide people that are using our software. Another component of the company, another line of business is broadcast television, large form factor touchscreens. You see them all the time. We're building a lot of that stuff. All the good stuff is us. The crappy stuff, like on ESPN, do you guys have ESPN right here, right? That's not us yet. Fox, that's not us. But CNN and everybody else, that's us. And building software for large form factor for people, for elite, rich people who don't know how to use an ATM machine is difficult. You know, John King and Anderson Cooper, and do you know who these people are? John King, Anderson Cooper, Wolf Blitzer. Really? It's because you have CNN International. These are like famous people. They make $10 million a year. They have agents, just like sports heroes, right? But they don't drive cars. They don't use ATM machines. They barely use their cell phones. You know, these are elite type people. Well, building software for them is difficult. It's all about user interaction design and stuff like that. So here's what we're going to talk about. I already mentioned it. I should casually mention that machine learning in the last couple years has just went and really changed our lives as developers. We don't have to be experts in machine learning. We don't have to know shit about machine learning, to tell you the truth, because for us, it's just a REST call. It's a service in the cloud, and anyone can do that. Even I can do that, make a REST call to leverage this computer vision stuff. If you ever seen me speak, you know that I'm more comfortable in front of a demo or Visual Studio than talking to PowerPoint, so I'm trying to get through all this stuff This is what I assumed you had seen before, because during the United States presidential election, you had to see this. 250 million people worldwide saw this. This is that big map of the U.S. and all the TV networks speculating on what happened, why were we so wrong, and things like that. Well, that's us building the software. But the journey started, or I guess I'm supposed to show you that. It's kind of interesting, actually. Here is this is the production bits, at least for the last election. Believe it or not, we are building interactive holographic software for the next election. So on TV, you're going to see some crazy stuff just visualizing data in an interactive way. But this is very 2D. I'm not allowed to wander. Here, let me use my mouse. You may remember, and you may have learned that in the United States, we have this bizarre way that we have voted for the last close to 300 years, and that the people really don't vote, we're represented. And that worked 300 years ago, but now with computers, it makes a lot more sense to just vote, right? But we have these weird traditions, and the loser actually won, which is fairly interesting. I'm from California. I live in Carlsbad. Whoops. See, I'm clearly not John King or Anderson Cooper. I live in Carlsbad, California, which is close to the Mexican border. And you could see that we had a heavy vote for the Clintons here, or Clinton here. We can go back. There's a history of this election. I don't know what I did here. Oh, it's trying to visualize something. There's a history of this election, and that we could go back to 2012 and go back to the Obama thing. I'm not a newscaster, and we don't need to spend any other time in this other than to tell you that this application is WPF, it's .NET, it's DirectX, because when you visualize on TV, it's got to be like that. So there's a lot of heavy lifting in the application. It's millions of lines of code, and it has to be up 24/7. You've heard frequently that, like the Azure is triple nines in uptime, right? You hear that all the time, triple nines. Well, 99% uptime, you know what that means? You're down once a quarter. Every 3 months you're down. That's 99% uptime. When you broadcast to 250 million people live, you can't crash the application. So this application runs 24/7, 365 days a week. Well, it doesn't run all the time because it's not always on TV, but it has to run, it can't crash, and believe it or not, it runs on Windows. So you can do that on Windows. That's supposed to be funny. All right, let's move on. What are we talking about here? Oh, I was supposed to tell you about the journey. So we also have this bizarre tradition. If you're familiar with the United States, you probably have never heard of a state called Iowa. That would get a laugh in the U.S. Iowa is completely flat. It's cornfields for thousands of miles. There's no structure at all. It's the farmland, the heartland of the U.S. We have this bizarre tradition in February of an election year, every 4 years. The good people of Iowa go to their local high school. The Republicans go to one high school and the Democrats go to another high school. Because there's not a lot of people in Iowa. And they're separated physically. Like, you people that vote for Clinton, you go to that corner. You people that want to vote for Sanders, you go over there. And then they're manually counted. You're looking at me like I'm crazy. It's the U.S. This is real stuff. And for hundreds of years, we've done this. So these people of Iowa get represented, and the guy or gal from the district of Iowa calls in and says, the good county of, I don't want to say the F word, middle of nowhere, Iowa, is voting for Clinton on the Democratic side. And then the Republican says, and we're voting for, Bush on this side, right? This has gone on for years. The uncanny thing about why I'm telling you this is because humans, especially Americans, are like sheep. So what happens in Iowa for the last 200 years has 99% of the time happened in the actual election. So if the good people of Iowa vote for Clinton on the Democratic side, Clinton becomes the eventual candidate. If they vote for Bush, or the other guy, I hate saying his name, then he usually becomes the candidate, right? Well, why am I telling you this? For the first time in United States history, we voted electronically, and we built the voting apps, actually 20 voting apps, to cover all major devices and all major platforms, including Windows. We had to build the Windows apps, which no one used, of course. But we did not get hacked. You know, we had a very successful night. The interesting thing was, and I doubt any of you remember this, but on the Democratic side, Clinton won, Hillary Clinton won in Iowa by voting in our app. And Barry Sanders, not Barry Sanders, what's Sanders' first name? Sanders, oh God, it's been so long. Anyway, Sanders is a liberal, got all the young people's vote, and he lost, and he bitched and complained the next day, but he's kind of a complainer. On the Republican side, Mr. Trump lost, and Marco Rubio, who you probably never heard of, won by a lot, right? Remember that, you know, for 200 years, the state of Iowa leads the U.S. into this. So Trump bitched and complained the next day. I went to bed happy because, you know, we were worried about the world, like the Russians hacking us, but everything went smooth, everything went great. All the Azure stats, all the servers that were feeding the media were keeping up, and we were doing great. I went to bed happy, even though we had these two losers bitching and complaining. In the morning, I woke up to this, a number of these, not just one, like the number of these hate tweets from the losing party. And Mr. Trump went public and said, you may remember this, you may not. He said, we know we won. I had people in every district in Iowa. That means at least 2,500 people counting votes. I had people in every district. We counted. We know we won. And you know what he was counting? The popular vote. Mr. Trump didn't even understand at that point how the United States election worked, that we're represented. I'm not kidding you. I am not, and I'm being recorded. I'm not kidding you. So push, and then I get all this stuff. Push comes to shove, we go to the Republican Party and we say, hey, listen, do you want us to explain to the Trump people how this works? Like that we have an electoral college and all this? And guess what they said? Exactly. They said, no, don't bother. You want to know why? They didn't think he would be the candidate. They just discounted him. They had no idea that he would ultimately be the Republican candidate and ultimately win. Do you find that interesting? I hope so. So then the U.S. goes, now we're in July, and the two political parties waste like hundreds of millions of dollars of our tax dollars having a 2-week party so that they could, you know, do this virtual vote of who their candidate is going to be. And this one you did see on TV. This is when Trump made that famous speech where he comes out from the dark, and it's complete BS. But all right, so here's one of the things that happened. Our children will be reading about this in history books on how he pulled this off, or if he pulled it off. As you know, there's a lot of people that speculate that the Russians actually hacked it. Understand that we built the voting app for the Iowa caucus. We didn't build the voting app for the presidential election. There are 50 voting apps, 50 different voting apps for the presidential election. Why? We have 50 different states, and they all contract people and companies to build their voting app. Talk about an attack surface, right? So it's legit to speculate that the Russians may have screwed with the results of the election. The other thing is we built this application. This is God's gift to running a campaign in terms of data visualization. This is a tool that we gave to the Republicans and the Democrats to manage the dollars, the hundreds of millions of dollars they get to influence votes. This is what these people do, right? That they influence the influenceable. You're the technology elite. You don't get influence. This isn't who they're trying to influence. In fact, they target so effectively that, say, a neighborhood that has 20 homes, they'll send a piece of mail to maybe 3 of them because they know those 3 homes are influenceable. And the Trump, for the last 2 elections, the Obama people have had the smartest software people in the world running the elections. And the Democrats kind of slipped this year, and the Republicans had a bunch of data scientists. And they used these tools very effectively to affect the vote in those 5 swing states. I'm getting too much into detail, and it's becoming no longer interesting. Just understand that the election was run by a lot of software and a lot of smart people. And there's going to be people who maintain that the Russians screwed with it, and then there's going to be people like me that said, nah, the Republicans use these tools and other tools, other companies, to swing votes and to convince what they call white middle-class America to vote Republican. Okay, whew. Can we move on to something else now? I was told you would be interested in that. I hope that wasn't annoying to you. Anybody remember what this is? You'd have to have gray hair to remember what this is. Anybody? Exactly. I rarely get someone who can recognize that. Because, I used to do all these Bill Gates keynotes, and he would always talk about Moore's Law. I don't care what anyone tells you, Moore's Law is still executing right on track. What is it? Dr. Moore, who wasn't a doctor at the time, in fact, he was just a lowly engineer that wrote a magazine article for some photography magazine or something like that, 60 years ago. And for the young people here, Dr. Moore predicted that every 2 years, we would be able to cram twice as many circuits on a circuit board. That's all he said. If you equate that to today, that essentially means how many circuits are on a CPU, right? And this is a little bit out of date, but you can see the Intel CPUs are up there calculating at 1 trillion calculations per second, or sorry, a trillion transistors on an actual CPU, right? Why do we care about Moore's Law? Well, first we should probably talk about Moore's Law. The prediction he made, Intel and AMD and companies like that actually do product planning based on the assumption that Moore's Law will continue to execute. That's important. So they're just making assumptions that curve, that line is going to go like this. All right? The implications of it are that software, by the time it gets to us, it's wildly powerful. These hardware guys and gals do this amazing thing, and we kind of catch up to them. And the stuff we do now in software is just incredible because our computers are so powerful. I'm standing in front of you as a guy who used to allocate memory to COBOL programs and assembly language programs on IBM assemblers, 30, 40 years ago. Garbage collection, right? We allocated our own memory to core, and we didn't have a lot of it. Cut to today, do we even worry about that? Compiles cost money when I started programming. Think about that, F5. How many times you press F5 in Visual Studio? And a compile costs money. If you made a syntax error, your boss yelled at you. Sometimes you got fired because you cost money compiling. Shoot, we hit F5 like 10,000 times a day. That's awesome. Here's what's interesting. This is Moore's Law as applied to the history of CPUs or computers against calculations per second. Stare really closely at the top right. Our computers or our CPUs are calculating at the speed of the brain of small rodents, or wallabies in your case. No, koalas in your case. But we are on track by 2025, I think it says, to to have our computers calculate at the speed at which a human calculates. Ooh, that doesn't mean machines will be smarter than humans. It just means they'll calculate as quickly as humans. That means that machine learning, the stuff we have trouble with now that takes months and months and months to do predictive analysis on, suddenly happens in seconds. The computer vision, what we're talking about tonight, means that we can recognize any object with speed and accuracy with commodity cameras. Means we can see weapons at distance, or we can look into the human brain and predict genetic disorders or disease. Just amazing type stuff. I hope you find that amazing. I do. So in different audiences, I have to explain that, you know, machine learning isn't a bunch of robots, and the robots aren't going to take over. And but if they do, they're going to forgive all our debt. So that'll be okay, right? That'll be the good news. Machine learning is just a bunch of smart people that are applying algorithms that need intense scale and speed. Tough problems that are really hard to solve without computers. Mapping the human genome, predicting genetic disorders, curing epilepsy, curing some cancers, things like that. And that's why I love it so much. So casually, this is the Microsoft stack for cognitive services. I'm fascinated in the vision part of it, but it does other stuff, other amazing stuff. Competition is a great thing in our world, and there are competitors to this. There are plenty of people that argue, including me, that Microsoft is, in artificial intelligence, Microsoft is significantly ahead solely because they spend more money than anybody else. And they still spend more money in R&D than any company out there in the world, but competition's good. It's good that Google is trying to do this, or is successfully doing this, and Amazon, God help us, and some other companies. But the best way to explain this, I hope you don't mind, I'm going to run this video, is by showing you a use case. This use case, well, let me just show it to you, and then we'll talk about its implications. 2-minute video.
I'm Saqib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind, and that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives, and one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do, but artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
So Huckaby is a real engineer, and that was a real proof of concept. And Huckaby programs in Visual Studio, and he did a presentation at Build and showed all of us how he does it, and it's freaking amazing. That's the good news. The bad news is that proof of concept is about 2 years ago, and at the time, because machine learning was in its infancy, he could only see 86 things. So, you know, I think that's a girl with a yellow frisbee. But if someone was playing rugby next to him, it would say, I don't know what the hell that is, right? Because 86 objects is nothing. Cut to today, or at least the demo I'm going to show you at the end, we have unlimited power, unlimited objects, so Huckaby actually can see because we've come so far in a couple years. And that's freaking cool. So, right? So let me push on here. You know, I get so wrapped up in the technology we do and the awesome things we apply to it that I forget that this stuff is so powerful that it truly can be used by bad guys. Computer vision can be Big Brother. It really can. And as developers, it's gotten so powerful, our stacks, that we have to be responsible about this. The CEO of Microsoft always talks about George Orwell and Huxley portraying this dystopian view where the machines take over and forgive our debt. And computer vision does have the power to be Big Brother. When you hear what we do in retail, you're going to shake your head like, oh my God, I can't believe that. Because it's dangerously close to Big Brother. But it also has the power to save lives, and that's the world I want to live in. Anyways, I'm supposed to tell you that, like in any technology, we have as developers, we have a duty to be responsible about this stuff. So what the heck is this? Let's see if yeah, perfect. Guess what this is? This would be Moet Hennessy, that giant booze company that makes Dom Perignon and numerous alcohols, scotch, that one of the biggest booze companies in the world. I'll nail it to them. This is a heat map of how people shop when they shop and are looking. Have you figured it out what the heck this is yet? We put cameras in grocery stores and 7-Elevens, and we use software to do audience measurement and produce analytics for big companies like these food companies, so they can make decisions on advertising. What does that manifest in? Well, it manifests in stuff like this. Don't pay any attention. Oh goodness, no, we don't want to do that. Oh shit, I'm gonna crash PowerPoint. Bear with me. You're not seeing what I'm seeing. I'm seeing PowerPoint crashing because I have all this beta cognitive services stuff on here. And there it goes. Let me try that again. And now Windows is freaking out. So let's do this. Sorry, I knew I shouldn't have installed that. I installed this cool add-in for PowerPoint because I speak internationally that translates me live from English to whatever the audience's native language is. It's amazing, but it crashes PowerPoint all the time because it's so beta. Let me get back to where we were. I wanted you to stare at the coolers, the refrigerators, and the freezers that are running all over the world. Oh my God, don't ask me again. That are running all over the world, like in this form factor. That's a cooler in a grocery store. That is an HD transparent touchscreen. This cooler's running Windows, and it has a little camera on it, and it's looking, well, first, it's trying to identify the humans in front of it. It's running engaging content, movement, trying to get you to look, right? Once you look, and we get a face, we get a skeletal structure of the human, we get the face, send it to the API, decompose it to a physics mesh, and a number of things happen. First of which, it switches from eye-catching content like this to what the consumer packaged goods company, giant food maker companies, Kraft, Nestle, Moet Hennessy, companies like that. It switches to what they want you to see, meaning it switches from this to a hamburger or a coupon or beautiful white people drinking champagne. And then it does a demographic profile. And if you're not in the demographic of the people on the screen, it changes to that demographic. It switches from beautiful white people drinking champagne to beautiful Asian people drinking champagne. Is that Big Brother or what? That's crazy, scary stuff. And guess what? It's wildly effective. Not to the elite, the technology elite. You're not consumers. They're not targeting you. They're targeting my wife and my son, my 22-year-old son. Right? People that are easily influenced. I'm in what they call a non-influenceable demographic, 50 to 60-year-old white male. If Beyonce says she's going to drink Diet Pepsi, I really don't care. I'm not switching to Diet Pepsi, right? Because I'm that get off my lawn type of guy. You know who's the most influenceable demographic? You could totally guess. It's not my wife's demographic. It's her gender. It's that millennial female, wildly influenceable. And Moet Hennessy claims a 25% uptick, I crashed PowerPoint again, in sales because of this type of thing. Being that said, it's also looking for the bad guy. So it's got a world bad guy database behind it. It's looking for stolen children. In the US, we call them Amber Alerts. In South Africa, it's called something else. I forget the name of it, but it's a problem worldwide. And in some cases, it's looking for loyalty. Let me see if I can get PowerPoint running without this add-in crashing me. Otherwise, we're just switching to demo. And we should at this point. Don't ask me again. No thanks. Did it work? Yay! Okay. So yeah, let's run if you guys, you two in the back don't mind, let's do that series of computer vision demos that we did earlier. So this is a UWP application. It really can be anything. Remember, because these, or did I tell you, all these cognitive services have REST APIs. It can be in any platform, cross-platform, doesn't matter. This happens to be a UWP application because, frankly, we made a mistake, and before I could stop it, it was like a snowball. I would rather have this be a web app, to tell you the truth. So I'm going to throttle the API to make 1 call per second. That means I'm going to pull a single frame of 30 out of the video feed, okay? And then we're going to analyze that. Realize that, I'm also going to do this on a commodity camera. This, you may not know this, but the camera in your smartphone costs $4 at quantity. So an iPhone camera is $4 at quantity. Now they have amazing software that really does magic with the pictures, but this has a USB housing or a casing and a USB interface, so this is a $20 camera. The reason I'm doing that is because this computer is a Surface Book. It has 2 magical cameras on it, one of which is a 3D camera. I'm doing the absolute worst possible test, right? Cheap camera, UWP app, and we're using the Vision API from Microsoft Cognitive Services. So, here I am. I'm using your network or the conference network, and we are calling Azure services out in the US. What? God darn, PowerPoint's killing me. Thank you, sorry. Kind of not an impressive demo if you're not seeing what I'm seeing. How about that? Can you see it now? I could see the reflection there. So first notice that, well, you missed the beginning part. The beginning part, it said like Tim Huckaby, 70 years old, and then we kept firing the API, right? It's getting smarter and smarter and smarter. I'm 55 years old. It should be relatively close to that. Now it says, wow, it says I'm a female today. Nice. It could be wildly accurate depending on the quality of the picture, right? Now this is a solved problem. This problem has been solved forever. Facial recognition has been solved for 2 years. What's interesting is on the right. Look at that control on the right. I'm afraid to look away because it'll call me a female again. That's an emotional profile. And because it said I was a female, my contempt probably went up to 2%, and my anger went up to 3%. I got to look at the camera, so I can't look at that. These are raw scores we get from Microsoft Cognitive. We're software people. We're not going to pretend like we know what to do with those. There are PhDs that know what to do with those scores. That ultimately, as machine learning helps and we train more and more models, we'll be able to score a propensity for terrorism, a propensity for suicide, to steal, depression, things like that, and send that type of data to the proper authorities. Big brother type stuff, all by looking at the face. Because of privacy law, we don't keep any pictures. We don't need to. I'm using pictures here because of the demo. Where this is all trig and calculus, and we build physics meshes with this stuff, right? It goes without saying, this is the retail product, and I always start with this because it's kind of creepy and like, holy shit, where's the world going? But we have a security product that uses common video surveillance cameras. There's probably one here in the room looking for the bad guy. Because there's lots of bad guys out there, and you know how the world is. So that's the engine. This app isn't styled on purpose. That's the engine that runs behind the software that we use. But you guys can do this at home if you want. Microsoft's cognitive services team provides this sample app and its source code so that you can do this same thing. Now I'm using the fancy Surface Hub camera. I'm no longer using the cheap one. These are the same bits. You can do this at home. You can apply this to your applications. You could build a security system for your own companies. You could, if you're in retail, you could look at audience measurement like we do for the people that are buying your products. And then, it's late at night, and I'm standing between you guys and cocktails, so trust me that you could all run up here and all put your face in the camera. This isn't a one-to-one thing. This sees as many people as the resolution of the camera. So some of these surveillance cameras we run the software on, they're magical. They see 1,000 feet in a 2-inch radius. Like the first demo I saw was a bird in a tree 1,000 feet away, and the camera followed it as it jumped from branch to branch and then flew away. Like amazing resolution for these surveillance cameras. Okay, so that's just to prove that you guys could do this at home. It's not all our proprietary stuff. But that's not as interesting to me as this. This, and the reason Moore's Law is important, and this is the single coolest technology that I have seen in years. And that's a bold statement coming from a guy that has built 3D and Kinect and Xbox and stuff like that for his career. This is the vision of objects. Remember, Shakib's problem was when he did that gesture on his glasses, it took a picture and he can only see 86 things. A year later, which is a year ago, he could see 2,000 things because of innovation. With this technology, the sky's the limit. This is Azure. This is the Custom Vision portal in Azure. Custom Vision is a poorly named thing. That's why no one's ever heard of it. It should be called Object Vision or Awesome. This is a machine learner for machine learning. The problem with training 86 objects for Shakib is it took thousands of man hours and tens of thousands of machine hours to train 86 objects. I can train this thing, and did train this thing, to recognize Cokes and Pepsis in about 20 minutes. So let's do that first. So this thing has the engine that these brilliant people built at Microsoft behind it. I have, 40 Cokes in my sample. Okay, and I have only 28 bottles of Pepsi. In this world 2 years ago, you needed at least 500 images, and good images. You can see a lot of my images are crappy, right? And you needed thousands of machine hours. But with a small sample of Cokes, Pepsi bottles, and Pepsi cans, I'm not going to do it in front of you, but I basically say train, and it does all the crunching on big servers in the cloud for me, right? Creates a classifier for me, and then produces the objects I need to call in a quick REST call. So I can do, from a digital perspective, I could do a one-to-one. We don't want to look there. How about, yeah, there we go. There's a Coke. We could do that type of thing. And it's going to come back and say, I'm 100%, well, I'm 99.9% sure that's a Coke. You may have figured out that also in retail, we look at Cokes and Pepsis and champagne and Kraft macaroni and cheese and stuff like that. And we do inventory and inventory disruption. That's the Coke guy put Cokes in the Pepsi cooler and vice versa. And then we do actual proof of purchase at acquisition point. So when my wife goes in there and grabs the Diet Pepsi out of the cooler, we can do the actual purchase based on that, right? But that's just looking locally. Here's another test container. How am I doing on time? I've got 10 minutes, right? We're going to make it. What do we call that? I call that rooster. Yeah. So again, this isn't styled. This isn't pretty on purpose. This is the engine that runs behind the thing. I'll go back to the cheap camera. And here's a Pepsi. And you can see immediately it nailed that, right? This isn't smoke and mirrors. This is real. And it immediately nailed that that's a Coke. That is impressive. That took me 15 minutes to build this classifier. But it's not the ultra demo. That's not the ultimate demo. That's just retail. Imagine a world where we're looking for disease. And that would be, so I met this gal, and her husband came this close to terminating her pregnancy because her son, who is now perfectly normal, 3-year-old, had a rare disease called posterior urethral valve disorder. It's 98% lethal if not caught immediately, but it's easy to catch if you're trained to catch it by looking at the ultrasound that is produced from a pregnant female. I guess only females are pregnant, but you know what I mean, right? It only happens in boys, but again, the trick was, and I met her in a totally different context. She happens to be an executive at Microsoft. And the trick is that if you're trained as a physician or some type of healthcare person, you could see it, but not everybody's trained, so it's missed. You know, and it's a fairly rare disease, so you've never heard of it. You know, there's only, I don't know, 500 babies in the U.S. a year that are dying from this, which sounds really crass and cold of me, but you know, compared to cancer, that's nothing, right? So I kept talking to her, and I kept thinking, like, God, I think computer vision can handle this. I'm confident So, you know, I kept learning more and more about this disorder, and you can see a bunch of pictures here. I've only got 40 normal. This is a bladder disease type thing, a dysfunction in the bladder, or abnormality in the bladder. I've got 40 what a normal bladder looks like, and then I've got 21 where they have this syndrome. This syndrome is that, see that little nodule at the end of the bladder? That's it. If you're trained to look for that, you catch it every frickin' time. So as you'd imagine, if I go out there, without further ado, like here's a normal bladder, and it's immediately gonna go, I'm 100% confident. I'm 99.9% confident that's normal. You interject this in the process, it takes 3 milliseconds to do this. Right? You interject this in the process of doing an ultrasound, and you're helping diagnose. You're helping save lives, which is awesome. So to show you it's not smoke and mirrors, let me grab one that has it. So here's one with PUV. I'll just grab that guy. And it's going to say, boom, I'm done. That took me it was 3 o'clock in the morning. I was so excited, and I didn't have anyone to call because I was in the U.S. I didn't know you people because you're a day and a half ahead of me. I could have called you, but it's 3 o'clock in the morning in the U.S. And so as you can imagine, if I just switch the classifier here to PUV, this is where it gets really interesting. So now I'm using software and a cheap camera. What did I do? What did I do with that? Bear with me. Oh, thank God. So check this out. This gal's name is Melissa Mulholland. This is a cheap-ass piece of paper, of a picture on an instant camera of a cheap monitor screen in a hospital room of her son that's now alive, right? So I'm giving you the worst case scenario, and if we can do, so boom, it nailed it. That's PUV. Right? You interject that the fact that you could do this, it's freaking crazy amazing. And here's a normal one. And it totally can tell the difference because it's just a computer. Did you see those identical twins today at the conference? Did you see those two kids? A computer always distinguishes between identical twins. It never gets it wrong. Humans are biased, right? We have trouble with them, right? I think I've made my point that now we've advanced from this. This is the big keynote demo at Ignite that I'm not supposed to show you that I just did in 2 weeks in the CEO of Microsoft's keynote. This is the big keynote. He had a son. One of his sons, Satya Nadella's sons, is severely handicapped because of a disorder similar to this one that could have been caught, and they missed it. So this thing brought tears to his eyes. So he's all stoked on this thing. Why did I tell you that? I can't remember. All right, so let's wrap this up and get you guys off to cocktails. Is anyone going on that boat cruise thing tonight? I'm going. I love to talk about this, so especially with cocktails in me, so please come see me. This is amazing. I can't demo this because it was kind of smoke and mirrors. They threw thousands, thousands of computers at this and thousands of cameras to identify everything in the room. And ultimately, to identify, look at the top right, a guy holding a tool that wasn't authorized to hold the tool, and it narking on him. Do you have that saying here, narking? The computer telling on him, right? So this is smoke and mirrors because it takes thousands of computers, and Microsoft threw everything at this to do a live demo of it. It's not realistic yet, but it's coming because of Moore's Law. Because we'll be able to, well, I don't know if we want to spy on our employees, but we'll be able to watch machines as they break down and maybe bad guys and girls that tamper with airplanes and things like that. Surveillance in a real time. So let me wrap this up by taking you a little bit to the past. Are you old enough to remember this? This was big for me when I was a teenager. But remember that this was just like a video. It wasn't interactive. It just played over and Obi-Wan Kenobi, you're my last hope, blah, 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 right? It just played over and over and over, right? Imagine a world where, you know, this is interactive. The only thing we can't do, and I'm not kidding, with enough money and resources, the only thing we can't do, only God can do this, I believe, is apply matter to a virtual object. Right? We can produce a holodeck, like in Star Trek, you know, where everything's virtual. You could interact and talk to people who are long passed away. In the U.S., you know, we love baseball, and Tony Gwynn, you've never heard of him, but he was on my team, and he passed away from cancer. And, you know, we could make virtual Tony, and we can talk to him, and it would look and feel like he's right there. Eventually, without the glasses on, right? Eventually, the projectors in the room are just going to produce the experience. We can do that already. It's just very wildly expensive. What we can't do is shake Tony's hand, right? And we can't produce ultimate porno platforms, right? But we can get darn close to interactive AR and mixed reality type scenarios. So this magical device is got a lot of competition, and that's a good thing. In the next year, you're going to see a lot of not virtual reality devices, which would be you've got glasses on, and the only thing you see is some shoot-'em-up game like that Xbox one. I'm not much of a game player anymore. Right? This is an augmented reality type of thing. You're seeing the virtual world, but there's just holograms or a different environment, like the movie theater thing. Like so when that airplane flies through, it's coming down the aisle, and you smell it and you hear it, and it's almost like it's there, right? I can't tell you what's coming. Just suffice it to say, in 3 weeks, Microsoft's going to make a bunch of announcements in their holographic technologies. Let me show you one I'm particularly proud of. Normally, I bring a Hololens, and you know, I put an object out on the stage, and I try to project it, but it's so network dependent, it's kind of janky. So if you don't mind, I'll just play a video of one. And I think it's this, and we can end it on this. So this is a DirectX application. It's kind of hard to do this in Unity, because what it's done is it's rendered a molecule in real time. This isn't a pre-rendered object. It's pulled down from the cloud an object and rendered this in real time, and it's cancer. And this application, ultimately, we're building this. This is just a proof of concept. But ultimately, this application will be used by scientists at one of the largest drug companies in the world that begins with an E, and oh, I showed you the wrong video. Eli Lilly, I might as well just tell you. This one I wanted to show you. Yeah. This is a newer prototype. And scientists are going to scientists get a theory in cancer research. I believe that I can cure pancreatic cancer by affecting this protein. I'm not a scientist, but in this protein, blah, blah, blah. But it's very hard to write a Word document that describes what they can do. Ultimately, you have to construct a molecule, right? This is going to allow scientists to construct molecules. Eli Lilly makes a magical device, a hardware device, that takes the description of a molecular compound and creates it, physically creates it, like 3D prints it. They already have this thing. And they let all their competitors use it for $1 million plus the IP. Okay, so a scientist comes in, and out comes a powder or a liquid or an aerosol, depending on the structure of the molecule that they create. And they take that away, right? And they do their drug tests and their drug trials, and ultimately it comes out and it's Prilosec or some cancer drug or something like that. You're watching these things get pulled down in a format they have in this world, a 3D format that's called protein database format. It's not XML. It's not any structured storage you've ever heard of. It's its own thing, but it's miles and miles of data rendered on the device in real time. And then the scientist is going to pull, we have to apply the laws of chemistry, so they can't create nuclear weapons and stuff like that. You know, they pull things down, they mount, and then out it goes. That is freaking awesome. I think that's awesome. And that's the world that I want to live in, as opposed to building software for the company that's killing the world with their cheeseburgers, which you have here in town, which we also do. So that's all I got for you. I hope that was entertaining. If you want any of this stuff, there's my email address. I don't have a place where you can download this, but I will put up a link so you can pull it down. I'm not going to save your email address if you email me. I'm not going to put you on a list. I don't even know how to do that. But I just don't have my act together to give you a URL where you can download all this stuff. Many folks use my decks to pitch their own companies, like, I want to do this. And you're more than welcome to do that. Okay? Any questions or comments before we go on the boat cruise and have cocktails? We can have questions and comments there for sure. Yes, sir?
Just one question about the holocule, whatever it's called, thing, yeah. How, in 20 years, a little bit, you think back to like the silicon graphics crystallizer systems that were used back in the 90s.
SGI computers?
Yeah, so, yeah, do you remember SGI? That's a system called crystallizer where you put 3D glasses on, track on the screen, and you would visualize molecules, protein folding in 3D. Not obviously nowhere near as good, but it's still, the technology was there 20 years ago. So I don't know if you know much about the technology. I'm just wondering, how far has it gone on? How different is that to what they were playing with?
Okay, I'm going to have to paraphrase that because you guys didn't hear, and that was long. So I'll do my best. I think the comment was, hey, we had 3D in this world 20 years ago, and we did. Yeah, and we built a lot of that software, but it was perspective 3D, and that was it. I'm talking about, you know, an interactive experience where you, I don't know if, I wasn't looking at what you were looking at, but the molecule is enormous, and you walk inside the molecule, and you're doing this and that. That's come a long way. But the biggest, I'm out of the video again, the biggest innovation we're going to see in the next, my prediction, and realize I get a lot of predictions wrong, and I make a lot of predictions. Every once in a while I'm right. My prediction is we will not be wearing glasses within 2-3 years. Because who wants to, you know, who wants to put on 3D glasses and walk through an airport? Right? It's just not going to happen. The rooms will produce the experience. And these things apply to Moore's Law too. These things are getting better and better and better. Yeah, that's when we have true innovation. Because, you know, a lot of these people, these people that don't know how to use an ATM machine, they're sure as hell not going to put on glasses. And scientists are like this too. They don't know how to use ATM machines or computers. I know a lot of scientists that are just completely focused on what they do, and everything around them is noise. Einstein was like that. Did you know Einstein wore the same thing every day? Did you know that? He just had like 5 of them because it was a distraction to him. I find that fascinating. Yeah. Does that kind of cover your question? I did my best. Anything else before we go on the booze cruise in the Sydney Harbor? All right. Great. Thanks for coming. I appreciate it. I'll see you there. Yeah.